This is the third part in our series on preparations of alkynes. We talked about the two different ways alkynes can be prepared. One is from smaller alkynes by sticking a group on the end. The other is by taking an alkene and turning it into an alkyne. So those are the two methods. In this video, I will be talking about how we use those reactions in synthesis. In other words, how can we make useful compounds using one or the other or both of those reactions. As I said in the earlier two videos on preparation of alkynes, this is all on section 7.5 on pages 260 to 262. Okay, so again, just to review, two ways of making alkynes. First is by what's called alkylation of acetylides. So first you take a terminal alkyne, one with a hydrogen on the end, take off the H+, that leaves a negative charge on that carbon, so this is now an acetylide. And then you add an alkyl halide. Remember, the alkyl halide has to be methyl or primary. And that new group adds on the end, and we now have made a longer alkyne from a shorter alkyne. In other words, one that's not terminal from one that was terminal. That's the first method. And the other method is from an alkene, where you take a molecule that has carbon-carbon double bond and hydrogen on each of those carbons, and take off the two hydrogens through a series of steps and turn the double bond into a triple bond. You either add bromine first and then two equivalents of sodium amide if there's another carbon group on that carbon, in other words, if it's in the middle of a chain, or if it's at the end of a chain, known as a terminal alkene, then you add your bromine and three equivalents of sodium amide followed by water, and that gives you your alkyne, essentially taking off two hydrogens and making an alkyne from it. So that's the second way. So if you're given a molecule to outline the synthesis of, should you choose method A or method B? So here's an example. Here is an alkyne with a total of 8 carbons, so this would be 3-octyne. And the question is, give two methods for synthesizing this compound. Well, here's the two methods. You could start with a shorter alkyne, in other words, a terminal one that has these 4 carbons in it, but has a hydrogen on the end, and then use sodium amide or possibly sodium hydride, and then add an alkyl halide, in this case N-butyl bromide, or N-butyl chloride will work just fine, and that would stick this N-butyl group onto that position in place of the hydrogen. There's the N-butyl group on the end of the triple bond, and you would end up with 3-octyne. Or you could start with an alkene in that same position, in other words, 3-octene. I happen to show this one trans, but it could just as easily be cis. And you add the element bromine to it. That adds bromine across the double bond, and then you add excess, or at least 3 equivalents, or I guess in this case, at least 2 equivalents of sodium amide, and that would take off the 2 hydrogens and take off the 2 bromines, and you end up with a triple bond. So either of the two methods would work just fine in this particular case. But in some cases, in a synthesis problem, you may be restricted to only certain kinds of reagents that you can start with, or certain numbers of carbons that you can start with. So for example, if I had said in the directions to the synthesis problem, you can only start with alkenes, then what would you do? Well, obviously you wouldn't use this method because this uses a compound that's not an alkene, and another compound that's not an alkene. So this would not work, but this is an alkene, and so you could use it to make that compound. But what if in the directions I'd said using any reagents you want, but no more than 4 carbons in each reagent? Then obviously you need to use this method because this is a 4-carbon piece, and this is a 4-carbon piece. So this is a legal, quote, legal reagent. This is a legal reagent. Now, if one of those had 5 carbons, you couldn't use that method. So you have to read the directions very carefully when it comes to synthesis problems. Let's say we did choose method A to make this alkyne. Notice that there's actually 2 different ways of doing it. You could have this 4-carbon piece with the alkyne at the end of it and react with this 4-carbon piece, or you could have this whole 6-carbon piece and have the triple bond at the end of it react with an ethyl group. So literally there's 2 different ways you could do this. So really 3 different methods in this case. This one plus 2 different ones using alkylation of acetylides. So how would you synthesize this from reagents of 5 or fewer carbons? So let's analyze this structure. And notice that it has 3, 4, 5, 6, 7 in a row with a methyl on the 2nd carbon, so that's a total of 8 carbons. And we could use reagents of 5 or fewer carbons. Okay, so how could we divide this up mentally? Well, if we were to use this 5-carbon piece, that would be legal because it says 5 or fewer, so a 5-carbon piece and a 3-carbon piece. We could use this as the acetylide, and this is the alkyl halide, this method right here, using this 5-carbon piece with an acetylide on the end of the triple bond, and this 3-carbon piece is the alkyl halide. That would give us this product, and so that would fit the bill. Or we could use this 5-carbon piece with the acetylide on that end of the triple bond, this N-propyl group already being there. In other words, this starting material, that's a 5-carbon piece, so that's legal, and then react it with the alkyl halide from this part, so that would be this alkyl halide. Would that also work? And the answer is no. Actually, this second one won't work because that carbon is secondary. This alkyl halide is a secondary alkyl halide, and remember the rule says only methyl or primary alkyl halides. So this alkyl halide won't work. If you try to put these two things together, you in fact won't get this product. You'll get something completely different, which we'll learn about in a later chapter. So it turns out that you got to choose your reagents carefully when you have two different possibilities for sticking a group on this end or sticking a group on that end. You got to choose the one that's going to use only methyl and primary alkyl halides. So here's an example. Outline the steps in an efficient laboratory synthesis of the following from an alkene. How would you make this from any old alkene? Well, we can't use the alkylation of acetylides because that requires that you start with an alkyne, and we can only start with alkenes according to the rules. So we're going to use the turn the double bond into a triple bond method. Just start with a double bond in the position where you want the triple bond to ultimately go. Add the halogen. In this case, I've chosen chlorine instead of bromine. Either one works just fine. And then choose a strong base. In this case, I've chosen sodium amide instead of sodium hydride, but they both work just fine. Notice also I put excess here. It really requires 2 equivalents, but if you put in more than 2, it's not going to hurt anything in this case. Here's a different example. Same product, but now the rules are different. It says outline the steps in an efficient laboratory synthesis of the following from reagents of 3 or fewer carbons. Now, this is a little tricky because notice this is an 8-carbon piece, and there's no way, even if you split it up right here mentally, this is a 3-carbon piece, but that leaves this as a 4-carbon piece. And so you're going to have to do the alkylation of acetylides twice. You're going to have to start with acetylene itself with a hydrogen here and hydrogen here, add one group on one end using the familiar sodium amide or sodium hydride, and then the alkyl halide. And notice that this would be a primary alkyl halide, so that's fine. And then you're going to have to do it again, take the hydrogen off the other end, again with sodium amide or sodium hydride, and again add an alkyl halide. In this case, the ethyl would be from the alkyl halide, and again that's primary, so that'll work just fine. So there's the outline. And here's the carrying out of the process. So you start with acetylene, add sodium hydride, that pulls off the hydrogen from one end or the other, obviously it doesn't matter in this case, and then you add, I've chosen to use the ethyl chloride first, that sticks the ethyl group on one end or the other, so there's the ethyl group on one end, and then do it again, so sodium hydride again, and then propyl chloride to stick the propyl group on the other end. So it's perfectly reasonable to start with acetylene itself and add both groups sequentially, first one and then the other. But don't forget, they both have to be primary or methyl. And that's the end of that lecture. Thank you.